Hi, so today I'll be solving the discussion problem for the chapter 4 video tutorial. So I chose question 19, which is where a specific Lamborghini has an initial acceleration of 0.75 g. Its mass with the driver is 1,510 kilograms. And then it's asking if an 80-pound or an 80-kilogram passenger rode along, what would the car's acceleration be? So to start this, we're gonna do with what we know. So the initial acceleration here, the first one we have is 0.75 g. The first mass is with the car with the driver, which is 1,510 kilograms, and then the second mass is adding on the 80 kilograms, and we're looking for the second acceleration with the 80 kilogram passenger. So I did a free body diagram here, kind of just to get things rolling, where we have the weight here, which is originally the 1510, and then we're going to add the 80 later on, and then we have the normal force, and then we have the force where we're going to assume the car is moving to the right. It doesn't really matter here, but I just added it here just to look, and we're looking for that acceleration on the second one. So to start off, what we're looking for the acceleration of the car with the passenger, and I'll represent this as A2, or acceleration 2. So we start off here with acceleration 1 equals 0.75 times g, which is the gravity constant of 9.8 meters per second. So acceleration 1 is equal to 0.75 times 9.8 meters per second, which gives us 7.35 meters per second. Then we have our second step. We're going to use the formula where force equals mass times acceleration. So in here, our first mass is 1510 with the car and the driver. And then we're going to multiply that times the acceleration, which we got from the step above, which was the 0.75 times the 9.8, which is 7.35 meters per second. So when we multiply 1510 times 7.35, we get 11,107.5 newtons. So then we're going to take this, where we have we're going to move on to find the mass of the second one, and this is the car and the driver plus the passenger. So we have the 1510 of the car and the driver plus the 80 kilograms of the passenger, which adds up to be 1,590 kilograms. So then we're going to take that, plug it into the next one, which is acceleration 2, which is force over mass 2. So what we have here, we're plugging in the 11,107.5 newtons over the mass of 1,590 kilograms, which is approximately 7 meters per second squared. So then we take the 7.5 meters per second squared, and we're doing the opposite of what we did above, where we multiplied it together. So this time we're going to be dividing by the 9.8 meters per second squared, and we're going to get 0.71 times g.